Hello guys, so welcome to the class. Now we are going to start exploratory data analysis. And again, in this video, we are going to consider the Red Wine Dataset. Now, if you don't know about Red Wine Dataset, guys, this is basically present in UCI machine learning repository. You can probably go and check out the dataset. You can check out what all information it specifically have, how many features it has. So just let me give you a brief overview, and then we'll try to understand what all we are going to do in the exploratory data analysis. Till now, we have seen feature engineering, we have seen about outliers, we have seen so many things, right? Now, EDA is all about understanding the specific data set that we have, right? So let me just go ahead and explain you about the red wine dataset. So this two dataset, the dataset are related to red and white variant of the Portuguese Vinho Verde wine. So this is a kind of a wine over there. So due to privacy and logistic issues, only physicochemical and sensory, the output variable are available. So if you probably see how many input features you have in this particular data set, you have something like fixed acidity, volatile acidity, citric acid, residual sugar, chlorides, free sulfur dioxide. So you also have total sulfur dioxide, density, pH, sulfates, alcohol, and the output feature that you specifically have is something called as quality score. Okay, so you basically have this quality score as your output feature. Now what we are going to do is that if you want to probably see the dataset, I have downloaded the dataset, right? And in this dataset, you can see these are all my features: volatile, citric acid, residual sugar, chlorides, free sulfur dioxide, pH, sulfate, alcohol, and this quality that you will be able to see, this is my output feature. Okay, so there are different qualities based on the different kind of wines that are available. Okay, and based on that, a label is actually assigned. The higher the quality, obviously the quality of the wine also increases. Now the main agenda of this session is that we will try to perform EDA on this, and we'll try to perform in such a way that we'll try to understand about this particular data, right? So this data is already downloaded, I have kept it, and this will also be available in your resource section. So what I'm going to do, first of all, quickly let's start this and we'll try to see what all things we can basically do. So first of all, I'm going to import pandas as PD, and this will be my data set where I'll write pd.read_csv with respect to this, and this will basically be my red wine. Let me just see wine quality red.csv, right? And now if I probably go and see my df.head, you'll be able to see this is how my data set looks like. Okay, now we are going to see most of the features are numerical over here, and this is basically my output feature. So let's go ahead and see that what all simple EDA we can probably do out of this particular data set. Now, as we go ahead, if I probably write df.info, right? So this is going to give me all the features that I specifically have in my data set. So here I have fixed acidity, volatile acidity, citric acid, residual sugar, chlorides, these all are there. And here it is also saying non-null. That basically means here you can probably see that I think missing values is not there. And if you also see the data type of all these features, these are like float, and the last feature is basically an integer value. Okay, so this is what df.info says. If you press shift tab, you'll also be able to understand what it does, right? This functionality. So it prints a concise summary of the data frame. And here you'll be able to see this entire concise summary, and you can see all the features that is basically using, right? So you can definitely see in this particular way. So here, whenever you want to see the summary of the entire data set, you can use df.info. So here I'll just write a comment, summary of the data set. Okay, so this is what we will be able to get. Now you will also be able to understand, like, see, there is a functionality which is called as df.describe. Okay, and if I probably press shift tab, here you can see that it generates the descriptive statistics. Now, what are the most important things with respect to the descriptive statistics? Probably you want to see the 25 percentile, 50 percentile, you want to see the 75 percentile, the minimum value, maximum value, the standard deviation, all those information you can probably get it through df.describe. Okay, so here are again what all features are there. You can see that all these features you'll be able to get it and all, right? So once I probably execute it, here you'll be able to see that, see, in fixed acidity, what is the count? Count basically says that how many total number of records are there. What is the mean for each and every feature? right? Each and every feature. So here quality is also been taken, but this quality will be my output feature, right? So what will be the mean? What will be the standard deviation? What is the minimum value? What is the 25 percentile? What is the 50 percentile, 75 percentile and maximum value? And this is with respect to all the numerical features we are able to see, right? So here we are basically getting a descriptive summary of the data set, right? Isn't it amazing? So once I probably execute it, here you'll be able to see the descriptive summary. Perfect. Let's say you want to probably see how many number of records and columns are there. Just go and execute df.shape, right? Once you do df.shape, here you are able to understand that you are having 1599 records and 12 columns, right? So here also you'll be able to see. Let's say you want to list down all the columns. List down all the column names, right? Column names. So here what you can do, you can just write df.columns, right? So here you will specifically be getting all the column names that are available in this data set. See, I'm not thinking with respect to machine learning prediction right now. We'll just focus on EDA, that is exploratory data analysis, and we'll try to understand many things about the data, right? Now, as usual over here in the description only, I've written the output variable is basically a quality, right? So if I go ahead and observe about df of quality, right? df of quality. So here you will be able to see that I'm able to see different values. But if I really want to understand how many different unique values are there, so I can just execute this unique function, and here you'll be able to see that I will be having this many number of qualities of wine. That is somewhere around 6, 1, 2, 3, 4, 5, 6, where this eighth value that is having, right, that is basically the quality of the wine. The more high the quality is, the more the better wine is. So there are 6 different types of wine that is available over here, right? So through this way you can basically find out the unique values that is probably present in your output feature. Okay, now the next thing that we are going to see is that is there any missing values in this, right? So we want to check the missing values in the data set. Now, in order to check the missing values in the data set, all I will do df.isNull.sum, right? So if I do this, here you'll be able to see that I'm getting 0, 0, 0 values. That basically means there are no missing values as such. If there was some missing values, we have already discussed so many different feature engineering techniques, so through which we can actually fix the missing values. Yes, we have seen about mean imputation, median imputation, mode imputation, different kind of imputation techniques altogether, right? So over here, definitely there is no missing values. Now, I also need to check whether there is some duplicate records. See, if I have in my data set some data, right? So what will happen if I have duplicate records? It will be of no use, right? And what I can do, I can also drop those duplicate records. So in order to find out the duplicate records, how do I find out the duplicate records, right? So how do I find out probably all the duplicate records? That is what we are going to see. So now for this, you can basically write df dot, and there is a function which is called as duplicated. Okay. So here you can see duplicated. So if I execute this, here you will be able to see wherever there is a duplicate, that will be true. Otherwise it will be false, right? Now, if I just want those records that are a duplicate, what I will do, I will just write on top of this my df values, right? So here you'll be able to see all these values. So total 240 records are duplicate, similar kind of values are present. Okay, so duplicate values are also way of remove, like we can remove this, right? If I probably just write not of this particular thing, I will get all the records without any duplicates itself. So definitely you can remove the duplicates also. Now for removing the duplicates, because duplicates will not play a very important role, right? So remove the duplicates. For removing the duplicates, all I will be doing is that I will write df dot drop duplicates. Okay, and if I want to make this operation permanent, so there will be a feature which is called as in place. So if I put this value in place is equal to true, so here you will be able to see that my entire duplicates will get. So see this df of duplicated, right? So if I probably see this df dot shape now, here now you have just 1359 records. Before we had 1499 records, I guess, or 1599 records. So that 240 records has been removed now, right? So through this way, we have simply removed the duplicates in this particular data. right? So I hope you are able to understand over here. I hope you are able to see what all things we are able to do it. Okay. Now let's go ahead and see about the correlation. How do I see the correlation? It is very much simple. All I will do is that I will write df.corr, and if I probably execute it, this is what is the correlation with respect to each and every feature, right? All these values you'll be able to see. If you want to see in a visualized manner, right, in a visualized better manner, so I will import Seaborn as SNS, right? And I will write SNS dot there is something called as heat map. Let's see, SNS dot heat map, and here in this heat map I will just write df dot corr, right? So by default Pearson Kurang correlation is there. Now here you will be able to see that with respect to different colors, right, you'll be able to see the relationship. Now if you want the values within this, if you want the values inside this, so what you can do in heat map, you have a feature which is called as annote. Okay, I guess this is only the annote part. So annote, right? So here what I will do, I will just make annote is equal to true. That's it. Now if I probably execute it, you will be able to see this, right? But still there is a problem because the values are like too much cumbersome. So what we can do is that we can probably set up the figure size with respect to the plotting, right? So here if I search for plot.fig size, okay, fig size in the Python, and let's see matplotlib. Okay, so I will just see the official documentation. It is very much simple, plt.fig, and you can probably say the fig size over here, right? So I'll do something like this, right? I will just import matplotlib, import matplotlib dot pyplot as plt, right? And then I will say plt dot figure, and here I will set up my fig size. Fig size is equal to, let's say 10,6. I hope so it works out. Fig size, this is there. Now I will just import this over here, and let's see the diagram. So now you can see that it is fit completely, right? So now my diagram looks pretty much better, right? So all I'll do is that I will just go ahead and copy this over here on the top. So I've selected my I've basically selected my entire figure size, that is 10,6, and based on that you can just see that how good your figure is adjusted, and you'll also be able to see that how one feature is basically related to the other feature, right? So through this way we are able to see our data set in a better way, and we are able to see that how good it looks like with respect to this kind of implementation, right? So in this, but why we are doing this, it is very much simple, guys. We really need to understand how good this is. Are you able to understand about the data set itself? Are you able to understand about the futures? Are you able to see some relationship? Is there some missing values? Are you able to drop the duplicate values? All these things will be there. Okay. Now further going ahead, what I can also do is that I'll just try to apply some more visualization. Okay, visualization. But I think we have practiced so many number of times now, different things. I've done feature engineering for you all, so many different examples we have seen. Now with respect to any data set, what all things you have to actually focus on. So if I write df of quality dot value counts, value underscore counts, right? So if I probably write value underscore counts, right? So here you'll be able to see that this fifth category is basically having 577 counts. So in your output feature. So this is definitely a imbalanced data set. In feature engineering, obviously, you know how to handle the imbalanced data set and all. You've seen about the SMOT techniques and all. So we can definitely apply all those things. But EDA, now here, you can definitely come to a conclusion. So what conclusion you are making over here? So I can basically write the conclusion over here also. Conclusion is that it is an imbalanced data set, right? So here definitely you are able to see this. Yeah. Imbalanced data set, because the number of categories is not at all equal with respect to all the output categories, right? So what you can do is that you can also, if you probably want to check out with the help of matplotlib plot, so I can also use a dot plot if you use, and here I can also use a bar plot, right? So if I execute it, so let's see what is the error. Series plot should not be called an argentine, only keyword argument. Okay, not a problem. So here value underscore counts, then dot plot, just a second, kind is equal to. So now you will be able to see this, right? Yeah, I did not put the parameter kind because inside this plot there are also other parameters. So it is telling to put positional keyword argument. So keyword argument is basically required, right? So here I can also put my x-axis and y-axis. So here let me put my x label. X label I can put it as wine quality, okay, and plt dot y label. Here we'll specifically put it as count, and finally this will be plot dot show. X label. So now here you can basically see the output and how it is basically looking, right? So there are different things with respect to this, okay? One more thing that you can specifically do is that you want to probably see the distribution of each and every feature, right? That also you can basically do. So guys, now let's say that I want to probably see the distribution of each and every columns that is available in the specific data set. So if I probably go and see df.head, right? So this is how it basically looks like, right? So if I want to see the distribution for each and every data set, so for I will just write for column in df.columns, right? And what I can do after this is that I can basically write sns.histplot. And here I can basically write my column name, okay, df of the column name, df of that specific column name. Along with that, what I will do is that I will also make sure I will write it as kd is equal to true, right? So I hope all the parameters are right with respect to this, and if I execute it, here you will be able to see for each and every features this kd plot has got mapped, you know, and this is how it is basically looking like, right? And every plot has basically been joined, so that is the reason there are a lot of overlapping in this, right? But if you want independently to see it, you can also write like this, sns.histplot, okay, and here you can probably write df of some, let's say alcohol. You want to probably see this. You want to see with the help of histplot, you will be able to see. So this way you can also check out all the distribution in a specific data set, and you can probably see that how the histogram is or how the PDF function is, okay? Finally, in Seaborn, there is also a very amazing thing. There's a functionality which is called as pair plot, okay? And this pair plot will be super important for the purpose of univariate. So here you can write univariate, bivariate analysis, right? And obviously you can also check out multivariate analysis. Like you want to compare one feature with the other and then the other features with the other, then you can probably use this pair plot. And here I will just give my df. So overall you'll be able to see this particular diagram where it will probably show that how one feature is correlated with the other features in a diagrammatical way. This will probably take some time for the execution because it is obviously it'll take at least 20 seconds to execute because there's so many features, there's so many different data sets altogether, right? So yes, I think now it will get uploaded. Till then I will just go ahead and show you categorical plot also. That is the next thing that is going to come. So categorical plot till this gets executed. And yes, this will take time, guys. This will definitely take time because there's so many data points. So this is how you'll be able to see it will look like. This is just comparing one feature to the other, and based on that you'll be able to see how your plots are, right? So negative correlation, positive correlation, based on that is how your data is basically scattered. Now I can also use categorical plot with respect to my output feature. So in Seaborn, you have something called as categorical plot, sns.categorical plot. And here in my X value, I will give my quality. Okay. And in my Y value, I'll give my another feature. Let's say I want to probably give alcohol or volatile acidity, anything you give, residual sugar. Let's say I want to give alcohol, right? So ALCHOL, alcohol. And then my data, which is my third parameter, will be my DF. And let's say I want to give it in the form of a box plot. Okay, so here there will be another feature which is called as kind, and here I can basically give my box plot, right? So if I execute this, here you'll be able to see with respect to quality and alcohol, over here I'm getting a categorical, see cat plot is basically just like a categorical plot. So if I press shift tab, you'll be able to see figure level interface for drawing categorical plots on facet grid, right? So here you can basically see alcohol based on this particular values. For this quality, here you definitely have outliers. On the 5th quality, you have a lot of outliers. On 6th also you have some outliers. So this way you will be able to see this categorical plot itself, right? And if you probably want to see, just a second, file save error, no worries. Okay, I've saved it. Let's reload this. So this kind of problem may also occur. Not a worries, I'll just reload it so that you'll be able to get it. Okay, so this is my categorical plots. Okay, so here I have to probably again use sns.pair plot. You can probably execute it, and then you can also use categorical plot, right? So for the categorical plot, it was very simple. All I will be doing is that I will be writing sns dot with kind of box. Now automatically I'll be able to see that specific plot. So when you are probably executing in this lab, right, PW skills lab, so sometimes this kind of issues will come. Definitely reload it, but it's all about scaling. That will take care of it. Will probably be saving the file also. Okay, so then we got to saw about the categorical plot. We saw the box plot itself. You can also use scatter plot, right? So here in SNS you also have something called a scatter plot. Okay, so sns.scatter plot. Let's say I want to see scatter plot with one feature like alcohol, a numerical feature. Specifically in scatter plot, we use numerical feature. So let's say alcohol, and the other feature that we probably want to use is Y. And let's say over here I have pH, right? And since quality is basically determining your output category, so here I can basically use Hui parameter, which will be a categorical value. So quality I can basically assign over here. Okay, and finally my data will be df. So if I execute this, there is some error. Let's see, could not interpret pH for parameter y. Okay, why pH is not there? Okay, because the feature, if I go and execute this df.head, let's see whether pH feature is there or not. P capital H. Okay, fine, P capital H. Now if I execute this, this is how my scattered plot looks like with respect to different qualities, right? With respect to 3, this is the color. With respect to 4, this is the color. I can also use another type over here with respect to this also. So I hope you have got an idea with respect to executing or performing an EDA with respect to the red wine data. So yes, this was it about this, and we'll again see different examples with respect to exploratory data analysis. But again, at the end of the day, just try to understand that EDA helps us to understand about the data, the missing values, the duplicates column that is available, or duplicate features, not columns, but at least duplicate data points that is available, the relation, the correlation between them. You'll also be able to see bar chart, you'll be able to see categorical plot, you'll be able to see pair plot. So different kind of plots, we can definitely check it out with respect to that, right? So I hope you were able to understand this particular video. I will see you all in the next video where we will be performing EDA for another data set.